Hey everyone, Eric Uzwa here, and in today's episode we are going to be continuing on our Project Moongate that I introduced in our previous episode. I'll put links in the description down below. And in this episode we're going to be covering a little bit of state machines and rendering. We're going to render a simple rectangle using the SDL2 rendering API. So stick around and let's get into this. Okay. So this is where we left things off at the end of the last video. We've got a window coming up with our Moongate title. Let's hit escape, get out of that. Oh, we'll fix that, not to worry. Okay. So as you can see, we've got our, we've got our snake engine definition within our main file of snake. So I think what I'm going to do first, before we even move on with Moongate, is just put that into some proper .h and .cpp files. Let's give ourselves the typical if and def header declarations. Okay, and we'll include our moongate.h, and back here we'll include our snake engine.h. Okay. And now let's just add an implementation file, a snakeengine.cpp. Include snakeengine.h, and basically we're just going to take the constructor out of here and put it into. There we go. Okay. So now, if we build it, we should see the exact same thing. Okay, right-click build. Okay, and I'll run it expecting that same error. There we go. Okay, probably just where I've got things defined, and the cleanup work where we're cleaning up our objects. So we'll get to that. We'll fix that with this video. Okay, so first we're going to talk about state machines. So right now we've got in our engine class, we've got our basic window renderer, startup, update, shutdown methods that we built in last time. So now what we're going to look at doing is adding support for a state. So if you're unfamiliar with what a state engine is, I think the easiest analogy, which a lot of people seem to use, is a traffic light. So a traffic light can be in red, yellow, or green. And then different things happen depending on what state that traffic light is in, what color that traffic light is in. So, for example, when the light turns green, when the traffic light is in the green state, then the pedestrian light starts counting down, starts the timer, basically allows it signals that you can now cross the street if you're a pedestrian, and it'll run through its regular, I don't know, like some lights give you 20 seconds, a countdown of 20, 15, something like that. Or, you know, you just have in the older traffic lights, you've got just a single pedestrian symbol, and then it starts blinking when it's about to change color. So there's a timer that gets kicked off when the state of the traffic light is in green, which kicks off that pedestrian timer. And then once the light turns yellow, all those pedestrian timers are cleared. And when it's in red light, then we show a do not cross pedestrian symbol. So either a red X or depending on the country you're in, etc., etc. I'll try and find some clippings, but I think you know what I'm talking about when I try to present that visualization. So we need the same type of thing into our engine. So there's lots of different states that a game can usually be in. So for example, we've got main menu. So even before that, we've got like a title screen, so a logo. So usually your game will have like a splash screen, like, you know, created by whatever studios. Then we get into like a title screen, main menu, where you've got, well, like a main menu. You go through options that you're allowing, you know, start new game, continue saved game, about, quit, that kind of thing. Then you get into anything like character creation. When you hit start for a new game, maybe you have to go through the process of creating a new character for yourself in this game, assuming you're working on some kind of role-playing game. So you create your name, create your stats, create the way your character looks depending on the game. Anyways, I think you know where I'm going with that. And then you get into the actual game itself. So that's yet another different state that you've gotten your game engine into. And I have to be careful because I think I'm using the terms game engine and game interchangeably. And really what I'm intending Project Moongate for is to build an actual game with. I don't want this series to be necessarily about building an engine. I want it to be like the whole purpose of this is to power some actual projects that I want to create. So I don't want to focus on just building an engine like some other tutorials or other projects around the web. I want this to be sort of an actual working game project, which just happens to have a collection, a framework, a library of objects that I can reuse in other game projects. So that's kind of where I'm starting from with this Moongate. That's where I'm intending this to go. And then the net result is I want to build a couple of role-playing games. So this project will be more or less leaning towards RPG, old school 2D RPG games. Okay, so with that out of the way, let's get talking about implementing a state machine in the Moongate. So what I've decided to do is I want to add a new item here, and we are going to oh yeah, we've got things separated out. So in the include folder, I want to create what I'm calling world.h. So there's a fantastic project out there that I used to use for making Flash games, and it's called Flashpunk. I'll put a link in the description down below, but a lot of that project is sort of inspiring me in Moongate here. And so in Flashpunk and in a lot of other game engines, you've got the concept of a world, which is basically a state. Okay, so let's create our standard, oops, if I could type, standard declarations here. So we'll include moongate.h. Okay. So we've got our standard if and def declarations. And let's create our namespace, Moongate, and then class world, and we'll just create a basic shell declarations right now. Okay. And then the intent is that we have to extend world in any of the projects or any of our uses of it. Okay, so typical destructor, and then we want a begin, a pure virtual function for begin, and a pure virtual function for end. And this way, a pure virtual function, if you're not used to using them, it basically means that we can't create an instance of a world class directly. The only way we can use it is to extend it, create another class extending this world object. Okay, and then we've got an update method that we want to use. So we want to update the objects that are in our current state, current world. And we also want to draw something. So let's allow our method to pass in our handle to our STL renderer. Okay, and then let's create a world.cpp. Let's go to source and of course. We want to create a new file. CPP. Let's browse to the source folder. select folder, let's call it world.cpp. Okay, and then we want to include world.h. And then I think we want to include, okay, we want to include moongate.h. We want to include world. And so we want to namespace our moongate and create basic constructor. Our destructors are already handled, so we want a body for update. And that will eventually fill in, and then we want a body for render, which will eventually fill in. Render is render. Okay. We can go ahead and add a body for begin and end, which will fill in later. So basically what I'm imagining is that when we are, okay, so now we've got these base methods defined. So let's go back into our engine, or let's first put this in our Moongate. Let's declare the object here and include world.h for other people to use or to be exposed. And let's, within engine, we are going to add a pointer to our current world, the current state that the engine is dealing with. So we'll just call it current world. And then we're going to have a public method called setCurrentWorld. So I'll have it return an int. And basically this gives us a way of setting the world, the current world that we're going to be using within our engine. So you'll see what I mean. Okay, so in engine.cpp, let's see, we go into the constructor and let's set our current world to be null pointer. Okay, and then so if, and then, oh yeah, and then we've got to set int engine set current world new world. Okay, so the idea here is that if we have an existing current world, then we want to call the end method. So basically the end method, the end override method gives us a way of sort of saving the state if we need to of anything that's going on in that world. So let's say the character's position in a game world, and we move into a different state, such as opening a menu, right? So while that menu is open, we want to preserve where we were in that game world, so that when we come back to it, our character hasn't moved, right? It's where we left that character. Okay, so if underscore current world is not equal to null, so if current world exists, then we call the end method. Cool. And then now we set the current world instance pointer to the new world. And then we call begin. Which will then set up, it'll run any setup of what's going on in the state. So if we have anything to initialize, anything to prepare before we begin using our world. And then we'll just return 1 for now. Okay, looks good. So now, in our update method for engine, what we want to do is, if our current world is not equal to null, then run the update method. So eventually we're going to pass in some timing stuff, but right now it's just an empty, we're just passing in nothing and calling our update function. So basically within our state, basically within our current state that's running, if we have any objects that we want to update, any objects that we need to update, then this is where we do it. And then, okay, so right here, right in where we put our to-do, So if current world again does not equal to null, then we want to call current world and render, and then pass in our STL renderer. Cool. Okay, so now we've got a simple way that this is coming together. So let's go ahead and build this. Okay, so now we've got it still in our static library. So back on Snake, let's create a snake world. So within snakeengine.h, we've got a moongate.h, our header declaration file. And so let's, we can call it, I guess we'll put it private. And let's declare an instance of, we can just call this snake world. It'll change, but for now, let's just call this snake world. World. We're going to change all this in the future, but I just want to kind of show you how we might implement this new state. Okay, so under Snake project, we'll add a new item into the Snake source folder. Let's just call it Snake World. Give our usual snakeworld.h, and we'll include moongate.h and some class snakeworld inherits from moongate world. Okay, so public, so snake world, and then snake world default deconstructor. Okay, and then we want to override. We need to override the update and render methods. So void update, and then I think void render STL renderer. Okay. So now in snakeworld.cpp, let's add a new item, our source file for snake world. Snakeworld.h. So we've got snake world. We're calling the world constructor. Oops, missed brackets there. Okay, and then we've got a void snake world update. And we can even just call the parent class update. Or the parent object. So I think that's if we just do world update. And then snake world render, and we pass in the STL renderer. Okay, so now in our engine constructor, let's see, I guess we can define this here. Actually, you know what? We're just going to, since this is a demo, we're just demoing the snake for now. So let's, in our snake engine, or in our world, or in our main, sorry, let's just add an include to snake world. And then right after the engine startup, let's engine set current world and new snake world. Oh yeah, and so back in snake world, sorry, it's giving us a red underline because we also didn't include the begin and end functions, override functions. So let's do that now. Void begin, void end, and we'll just give them empty bodies for now. Snake world begin. We'll call the parent world begin, and same thing with snake world end. We'll call the ominous world end method. Okay, why is it? Okay, there we go. And so now it should be able to build. And I left off. And end if at the end of this file. And what about engine? Yep, just making sure that's all right. All right, so let's build that. Okay, so we built that, no issues. And then if we run it, hooray! And we fixed up our memory error. Hooray! I told you that would go away. Okay. So what we can do with our SDL renderer is we have to use the drawing API that's built right into SDL2 itself, of course. That way it keeps it cross-platform and cross-renderer platform. So if you're on a Mac, then I think by default you're using the OpenGL SDL renderer. And if you're on Windows, I think by default you're using the Direct3D. So let's first create a SDL rect structure. And I'll just give it a 250, 150, 200, and 200. And I'll explain what this means right here. I'll just put in a quick comment. So this is the same thing. Using this shorthand declaration for SDL rect is the same thing as typing in rect.x of 250, giving it a y position of 150, and giving it a width of 200 and a height of 200. Okay. And then what we're going to be using, we're going to change the color so that we know that we're actually drawing something. So we're going to be calling a method called SDL renderer draw color, which takes in our pointer to our renderer and then our RGBA color values. So for right now, let's use white, which is 255 across the board. Okay, so we set our color to white, and then what we want to do is we call another function called SDL render draw rect. Okay, so this will draw the outline of our rectangle. So it'll take in our the address of our SDL rect structure, and then it'll draw a white outline of where that is. So let's give it a run. Hopefully I've got everything defined correctly, and here we go. All right, that's pretty cool. So we've got our state machine, our basic state machine going, and we've got a basic rectangle coming out. So what we can do is we can play with the methods here, and instead of draw rect, we could call fill rect. I think it's called fill rect, and this will draw a rectangle with it completely filled in. Ta-da! As we see right here. And then we can go back and change the color. So let's try just red. So let's try giving a green and blue values of 0, and let's try running this again. And we get red. Amazing. Cool. So I'm going to go back and just keep it at the border, rectangle border. Keep this color white. And you can download this code from my GitHub, and you should be using, I'm trying to use tags, git tags, to separate what I'm doing between each video. So in this video, this will be, I'm just going to call the tag video 2 for lack of a better description. So when you pull in, when you clone the, or not clone, but when you check out a branch, you can check out a tag as well. So you can check out the video 2 tag if you want. And just so that we see this in action, let's update our logging here, just so that we make sure that these are even being called. So let's call the snake world. Sorry, this is just a geeky way of making sure that things are being called the way you want them to be called. We kind of proved it already by calling the renderer, displaying our render stuff here, But let's go ahead and in our world, we'll just call SDL log begin and SDL log end. Okay. Let's see, we've properly defined them. Oh yeah. Sheesh. Leaving off a semicolon. Okay, so if we run it, let's try this again, everyone. Okay, there we go. Whew! Makes me feel a little better. All right. So we've got the log for our engine constructor, and then further on down, we've got our snake world begin method, which calls begin underneath the covers, the world begin. And yeah, we've got our proper rendering here. All right. So that's the end of this video. I think that's where I wanted to leave things. And next time I'll be adding a few more cool things. And I think maybe next time we'll tackle keyboard input and maybe making our rectangle move around. That's kind of important, right? When you're working on a game. All right. Anyways, hope you enjoyed today's video. Give it a like and subscribe to the channel, and we'll see you next time, everyone. Have a good one. Peace.